This meeting is being recorded.
Hello everybody, this is Torsha Chatterjee from Executive MTech AI 2023 batch. So today I will be walking you through one of the research paper work, LongReward, Improving Long Context Large Language Models with AI Feedback. So first we will check with the motivation. Why long context LLMs still struggle? So in recent years, large language models have begun to support very long input context, for instance, hundreds of thousands of tokens. That opens up downstream tasks like long document understanding, summarization, and multi-document QA. However, most supervised fine-tuning SFT data for long context is automatically synthesized by LLMs rather than human annotated. For example, long text QA pairs are often generated by LLM themselves. So these auto-generated data suffer from quality issues, like they may contain logical mistakes, hallucinations, and full long context effectively they may not use. So as a result, even though the models have access to long context, but their performance in long context tasks can still be compromised due to data quality. Like in the other hand, short context instructions following reinforcement learning or AI feedback has been shown to improve models' alignment with human performance. But in long context setting, how to obtain reliable rewards or feedback remains largely unexplored. So our motivation that can we design a reward mechanism for long context LLMs that can scale and truly improve long context performance. And that only leads to the proposal of LongReward using an off the shelf of long as a judge to give reward signals on four human valued dimensions like helpfulness, logicality, faithfulness, and completeness. So, what is our goals and contributions here? Our main goals is to create an automatic reward estimation method for long context, integrate the reward into an offline RL pipeline, especially using direct preference optimization, that is DPO, for long context models, and empirically validate an open source long context model that improves long context tasks and does not harm short instruction performance. So, in short, it is to address the gap of reliable reward in long context LLMs and demonstrate its efficacy. Now, we will go through the algorithm or methodology that the model follows. So, first, it starts with the preliminaries, that is the RL and TPO for LLMs. So we view the model policy as generating response Y given prompt by input X. We need a reward function R X comma Y that reflects goodness of response. One common algorithm is DPO, which takes preference pairs X comma YW YL, where YW is preferred over YL for same prompt. The objective here is that it maximizes the log difference of probabilities of winning versus losing responses. TPO is more convenient than than example PPO. No need for online sampling of new policy models. Now, one by one, we'll introduce the long reward context. So, in the key challenge for long context scenarios, we lack scalable, reliable reward estimation. That's why we propose long reward. Use an off-the-shelf LLM to score a response Y given context C plus query Q. The input is long context prompt x equal to c comma q, etc. So we evaluate the response on 4 dimensions, that is helpfulness, logicality, faithfulness, and completeness. Now we will see that how each dimension is assessed. So for helpfulness and logicality, since they are largely independent of the context, helpful uses query plus response and logicality uses response only. Here we use few shot prompting with chain of thought COT to judge the LLM, to analyze and score. For faithfulness, we first decompose the response into atomic factual statements by sentence that are not just conclusions or functional sentences, of course. Then for each statement, retrieve top K context, that is chunks, example 5 chunks or 10 chunks, and ask judge whether the statement is fully, partially or not supported. We score fully 1, partially equal to 0.5, none 0, and then make the scale to range between 0 to 10 range. So here in this overview, the flow chart is given basically that how the long context user query is coming to the multi-dimensional LLM scoring and passing through the helpfulness, logicality, faithfulness, and completeness. And from response 1, 2, 3 is giving the score as like 7 out of 10, 5 out of 10, 3 out of 10. It's arranged in descending order. And next for completeness, so we divide the long context into coarse chunks, example like 4096 tokens. From each chunk, we ask the judge to extract question relevant information. Then concatenate this and ask judge to evaluate whether the response covers all extracted information via few shot plus COT. Here also producing a score ranging from 0 to 10. So if I put all it together, LongReward plus DPO, the pipeline is take a long context SFT model for a given prompt X, sample M candidates, example 10 using temperature sampling. For each candidate Y, apply LongReward to compute reward R x comma I1. For each prompt, choose the highest reward response as winner YW, train with DPO objective, and finally yields a fine-tuned model that is preference optimized. Now we will go through the experimental setup. So here we used two open source context based models. One is Llama 3.18b and GML49b. Each supports up to 128K tokens context. SFT dataset, we took 10K long documents, 8K to 64K tokens from the pre-training corpus, generated QA pairs via self-instruct from a model, mixed with the large general SFT dataset. For constructing preference data, sample 10 candidate responses per prompt, use our LongReward scoring. Now, we will look on the evaluations and results observed. So, long context task results on the benchmark, long bench and long bench chat. The DPO model with LongReward substantially outperforms the SFT baseline. For example, with Llama 3.18b, SFT gets 56.6 average. I will show the number 56.6 average and 59.9 average, making a difference of 4.9%. With GLM 49b, improvement of 5.5%. On a fact score, SFT on Llama gets 21.76 facts. DPO LongReward gets 32.86 and it improves from 91.94 to 92.85%. And if we check the human evaluation on long bench chat, uh, the LongReward versus SFT baseline, overall win rate is 54% versus 8% loss, which ties to 38%. Across each dimension, helpfulness, logicality, faithfulness, and completeness, the DPO model had more weights. So, in short, this is the results and evaluation we have got. So, uh, mm, finally, we can conclude that the LongReward can help in future long context models to be more helpful, logical, faithful, and complete. Thank you.